very first time an item from interstellar space has been seen to visit our planetary group in the tremendous field of the universe. Humankind has simply started to expose investigation in spite of our restricted comprehension. We've long contemplated the possibility of extraterrestrial life, contemplating whether we're distant from everyone else in the universe. But everything changed with the appearance of our most memorable interstellar guest, Oumuamua. Unlike anything we've experienced before, this mysterious item left us in awe of what lies beyond our reality. Astrophysicist Neil deGrasse Tyson stunned the world by revealing never-before-seen declassified pictures of Oumuamua. Who sent this extraterrestrial courier? What is the YP effect and how can it connect with Oumuamua? Join us as we venture into space guided by Tyson's disclosures, unwrapping the mystery behind this peculiar interstellar explorer. In 2017, a notable discovery modified our impression of our position in the tremendous universe. Using the Pan-STARRS 1 telescope, astronomers detected an unusual object floating towards Earth. The visit of the puzzling flying object Oumuamua started a significant unrest in how we might interpret space and its prospects. Notwithstanding its fame, our insight into Oumuamua stays restricted because of public interest. Astrophysicist Neil deGrasse Tyson has uncovered previously undisclosed and profoundly classified pictures of Oumuamua, shedding light on its inestimable importance for our planetary group. On October 19, 2017, stargazers at the Haleakala Observatory in Hawaii mentioned a historic observable fact. At first accepted to be a comet or space rock, further examination uncovered it as the main interstellar object identified within our planetary group. Barring dust grains, Oumuamua, named Oumuamua, signifying a courier from a remote place, showed a skewed orbit and rapid speed, suggesting origins beyond our nearby planet group. Oumuamua's irregular splendor defied simple explanation, leading scientists to infer its exceptionally elongated shape, igniting hypotheses about its origin and purpose. One hypothesis suggests flowing powers cause its stretched shape, while others propose gravitational communications within its home star system or binary star frameworks. Oumuamua's striking speed increase, much like a bike suddenly gaining speed without accelerating, adds to its mystery. Its rapid speed surpassing any human-sent object suggests origins from a binary star framework or gravitational interactions with heavenly bodies impelling it on its interstellar journey. Besides, Oumuamua showed wild swings in splendor named the YP effect, which represents Yarkovsky paddock. This effect occurs when sunlight warms up one side of the article, making it emanate warm radiation unevenly, hence making small powers that can adjust its direction. This peculiarity might make sense of Oumuamua's irregular speed increase and strange qualities. As we dig further into the complexities of Oumuamua's excursion, the disclosures from Neil deGrasse Tyson's pictures and continuous exploration keep on disentangling the secrets encompassing this perplexing interstellar voyager, offering insights into the immense and captivating realm of our universe. This system is usually used by space missions utilizing the gravitational draw of planets during flybys to acquire speed. But further examination is necessary to decide the probability of such experiences and their commitment to Oumuamua's speed. However, there's something else to Oumuamua besides its speed. Studies have revealed intriguing insights concerning its arrangement. It has a thick external layer like an enormous shell made of carbon-rich materials that's cemented because of grandiose radiation during its broad gaze through interstellar space. Underneath this defensive outside, Oumuamua reveals its amazingly thick internal nature, fundamentally made out of rock and perhaps containing components of metal. What separates it is the shortfall of water or ice which recognizes it from common comets or cold heavenly bodies. Moreover, Oumuamua's surface has a ruddy color coming about because of drawn-out opening to infinite beams north of a huge number of years. Scientists have likewise viewed as the likelihood that Oumuamua's high velocity is an outcome of its shape and organization. Then again, a few people have mentioned the commitment of famous specialists like Neil deGrasse Tyson and Michio Kaku to the conversation around Oumuamua. Strangely, Neil deGrasse Tyson avoided remarking with regards to this issue until significant proof and the as-of-late grouped photographs opened up, leaving everybody anxiously expecting his viewpoint regarding the matter. A few scientists recommend that the article's prolonged structure as induced from its light bend shows that it very well may be a piece of a bigger body. Assume Oumuamua severed from a bigger item because of a crash or other rough occasions. All things considered, it could have obtained significant speed during the division interaction. This would suggest that Oumuamua's speed isn't characteristic for its inclination, yet rather a consequence of previous occasions. Comets, for example, navigate our planetary group at different speeds, while certain comets can accomplish speeds tantamount to Oumuamua's, for example, Comet Sound Bob. They ordinarily display leftover gas and residue because of their unstable synthesis. Conversely, Oumuamua showed no such qualities, distinguishing it from known divine articles. One more examination can be made with space rocks, rough items that circle the sun. Most space rocks in our planetary group move at altogether more slow paces than Oumuamua's. For example, the normal orbital speed of the notable space rock series is roughly 17.8180 kilometers each hour, under a fifth of Oumuamua's speed. This dissimilarity underlines the excellent idea of Oumuamua's speed and its qualification from natural planetary group objects. Here's where things become much seriously charming. A few specialists estimate that Oumuamua could be in excess of a normally happening object. They recommend that it very well may be a misleading created creation fastidiously made by a high-level extraterrestrial human progress. Oumuamua might be essential for an unbelievably progressed outsider spaceship or gear intended for investigation. As per this hypothesis, Oumuamua's interesting elements could serve different capacities. Its elongated design could upgrade its versatility during interstellar travel, while its impetus framework could empower exact moving through the universe. Famous figures like Avi Loeb, an Israeli-American hypothetical physicist and cosmologist, emphatically trust this hypothesis. Loeb even proposed a disputable speculation that Oumuamua could be of extraterrestrial beginning, recommending that it very well may be a fake object or even a piece of outsider innovation. He contended that its unconventional properties, like its prolonged shape and strange speed increase, could demonstrate a fake beginning. Loeb's hypothesis created inescapable conversation and discussion inside established researchers. In any case, it is essential to take note of that numerous researchers and stargazers have communicated suspicion about his cases. The prevailing view among most researchers is that Oumuamua is likely a characteristic object like a comet or a space rock, with its uncommon properties being the consequence of normal cycles. Wesley C. Fraser and different scientists consolidated splendor estimations from various telescopes to examine a revolution period. They inferred that no revolution period can represent the noticed splendor varieties. All things being equal, the object seems by all accounts to be tumbling in an energized rotational state. This uncommon and impossible to miss tumbling movement was not normal for anything seen previously. Theories propose this sporadic revolution has astounded researchers since its disclosure. Observations made by space experts have given important experiences into Oumuamua's twist. It finishes a full revolution each 7.3 hours, which is somewhat quick contrasted with the rotational times of different articles in our nearby planet group. Furthermore, its splendor shifts essentially as it turns, demonstrating that various pieces of the object reflect daylight to fluctuating degrees. This unpredictable revolution has baffled researchers and prompted different fascinating speculations. One hypothesis proposed to make sense of Oumuamua's twist is the twist-instigated outgassing hypothesis. As indicated by this thought, unpredictable substances underneath its surface are presented to sun-based radiation as the article tumbles through space, making it disintegrate and make small gas jets. These planes go about as engines, giving a force on Oumuamua and making it turn unpredictably. This suggests that Oumuamua's creation might contain unpredictable material helpless to sublimation influenced by sun-oriented radiation. However, further investigations are expected to affirm if this system is liable for Oumuamua's exceptional revolution. Another hypothesis proposes that Oumuamua's tumbling movement could result from an earlier impact with another object. It is possible that a fast effect mutilated its shape and set it into a sporadic twist. This crash could have happened in the object's home star framework prior to being shot out into interstellar space. However, the specific nature of such a crash and the object included stay speculative because of restricted observational information. Definite investigation of Oumuamua's shape, arrangement, and surface elements could give pieces of information supporting this hypothesis. To better contextualize Oumuamua's unconventional development, how about we inspect other heavenly objects with comparable ways of behaving? One such object is the space rock 4179 Tatatus. This extended space rock found in 1989 shows a tumbling movement similar to Oumuamua. Researchers have proposed several hypotheses to make sense of Tatatus' flight pivot, including the Yarkovsky-Paddock effect. According to this effect, sunlight applies a force on the object due to lopsided warm radiation, step by step modifying the space rock's revolution, prompting its sporadic tumbling movement. While this mechanism could likewise apply to Oumuamua, its precise job stays unsure. Curiously, another comet 67P/Churyumov-Gerasimenko likewise exhibits an unpredictable revolution. Analysts found 67P on September 11, 1969. This comet circles the Sun and shows a striking shape and unmistakable development. It highlights two unmistakable curves associated by a tight neck, giving it a unique appearance frequently contrasted with a rubber duck or a bowling pin. Scientists have named the bigger curved body and the more modest one head. The comet's circular circle finishes one upheaval around the Sun in roughly 6.45 years. It has a place with the Jupiter group of comets, demonstrating that its starting point can be followed back to the Kuiper belt, a local past Neptune populated by cold bodies. Nonetheless, specialists accept that gravitational annoyances brought about by Jupiter's monstrous gravity caught 67P into its ongoing circle. This recently concentrated on comet goes through different changes in speed and distance from the Sun. On account of Oumuamua, researchers accept that the outgassing of unstable substances from the comet's surface assumes a critical part in its tumbling movement. As the ice on the comet's surface disintegrates influenced by sun-based radiation, it makes restricted jets that behave like engines, modifying the comet's pivot. The likenesses among Oumuamua and these objects allude to potential fundamental systems answerable for their uncommon twists. Further investigation and definite examination of these objects can give significant bits of knowledge into the nature of Oumuamua. The beginning of Oumuamua has likewise been a subject of extraordinary hypothesis. Several scientists recommend that it very well may be a part of a larger body launched out from its home star framework because of gravitational communications or a horrendous occasion. This release could have granted an underlying twist on Oumuamua, which has persevered all through its interstellar journey. The exact cycle by which Oumuamua was catapulted and its resulting directions stay unsure, highlighting the requirement for additional information and further exploration. There is a plausible chance that Oumuamua's absence of emanation could be made sense of by it being a dead comet. An ordinary comet's frigid organization disintegrates as it moves toward the Sun, bringing about a discharge trail. The ramifications of Tyson's hypotheses are immense, going from mechanical progressions to philosophical introspections. They disturb ordinary astrophysical speculations and potentially reshape how we might interpret the universe. If any of his hypotheses hold, it would check a critical change in outlook and drive us into another time of room investigation. Gratitude for watching. Look at the video you see on your screen at the present time. It's mind-boggling.